Hi, I'm Talia. I'm a high school senior and I love chemistry, math, and teaching others about chemistry and math. This YouTube channel is an extra resource for anyone who may be needing some extra help in their chemistry classes. This week, I'm going to be continuing from last week's video about mass-to-mass stoichiometry and talking about percent yield. So if you need help with learning about percent yield, feel free to keep on watching. Without further ado, let's get started. Okay, so in the past video, I taught you how to calculate the mass or moles of a product or reactant in a reaction, and that is the theoretical mass. And the theoretical mass is when everything works out perfectly and you get the exact number of grams that would be calculated by the end of the reaction. However, that is not always the case. Sometimes due to human error, you might end up with more or less mass of a certain product, and that is where percent yield comes in. So percent yield defines the actual amount of product that is obtained in the reaction. Because, like I said, side reactions, contamination, or other processes can cause the calculated or theoretical mass to not equal the actual mass of the products that are produced. So to calculate the percent yield, you divide the actual mass by the theoretical mass and multiply by 100. So percent yield questions will be formatted in a plethora of different ways. You can be given different information and asked to find different things. There's a full range of kinds of questions that you can be asked about percent yield, because the percent yield for one product will stay the same for all of the products. So if 80% of product A is actually produced, that'll be the case for product B as well. So we are going to do an example with calculating percent yield. So our problem is that magnesium chloride reacts with silver nitrate. So we are going to write a balanced chemical equation, and we have two questions to answer. If 21.2 grams of silver nitrate reacts with a percent yield of 80%, what mass would actually be obtained for each of the products? And if 476 grams of magnesium chloride actually produces 400 grams of magnesium nitrate, determine the percent yield of the reaction. What mass of silver chloride will be produced? So these are kind of two different situations. So I'm going to draw my stoichiometry table twice. So let's first do part A/B, like the first question. So I'm going to first write my balanced chemical equation. I'll do it up here. So I have MgCl2 and AgNO3, and that is going to yield MgNO3 2 and AgCl. Now I just want to balance it. So I'm going to put a 2 in front of the AgCl and a 2 in front of AgNO3. And then we have the same number of each element on the reactants and product side. So for this first part, I'm going to rewrite my reaction. Okay, so now that I have set up my table with my balanced chemical equation, I'm going to enter my given mass, which is silver nitrate, and I'm going to figure out what I need to find. So I want to find the actual mass for each of the products. So I'm going to first start by converting AgNO3 into moles. So I'm going to write 21.2 grams AgNO3. So I'm going to first start by calculating the molar mass of each of the chemicals in the compound. So we are going to start with MgCl2. So we have 24.31 plus 2 times 35.45, which equals 95.21 grams per mole. For AgNO3, we have 107.9 plus 1401 plus 3 times 16, which equals 169.91. For MgNO3, we have 24.31 plus 2 times 14.01 plus 6 times 16, which equals 148.33 grams per mole. And for AgCl, we have 107.9 plus 35.45, which equals 143.35 grams per mole. Okay, now I'm going to convert the grams of my given substance into moles. So I'm going to write 21.2 grams AgNO3 and multiply by molar mass. When I multiply or divide by molar mass, it is per 1 mole of the compound, not the same number of moles as the coefficient in the reaction. And then that is going to get me 0.125 moles of AgNO3. Now in my last stoichiometry problem, I converted to moles of each of the compounds first and then grams. I'm going to combine those conversions into one this time around, but if you need to do it in 2 steps, that's fine too. So I'm going to go straight to finding theoretical mass of MgNO32. So I'm going to write 1.025 moles AgNO3 times 1 mole MgNO32 per 2 moles of AgNO3, and then I can multiply by the molar mass of MgNO32, and then these units cancel out, and I can just go straight ahead and multiply. So I'm going to divide by 2 and then multiply by 148.33 to get 9.25 grams of MgNO3 and that is theoretical. Okay, now let's find the theoretical mass of AgCl. So I'm going to use the starting moles AgNO3, just like in the last problem, and I'm going to do the same process. So I have 2 moles of AgCl per 2 mole of AgNO3. So you could stop here and write moles and then multiply that by molar mass to get mass. I'm just going to keep going. Do times 143.35 grams over 1 mole AgCl. So then multiplying and dividing by 2 is just like multiplying by 1. So I'm going to just multiply by 143.35 to get 17.9 grams of AgCl. And again, that is theoretical. Okay, now we're not done because the problem asks for the actual mass of each of the products. And we're given a percent yield of 80%. And we know our equation for percent yield is actual mass over theoretical mass. So we have our theoretical masses. So let's start with MgNO32. So if I'm going to call my actual mass X. So if I have X over 9.25 times 100, because percent yield is actual over theoretical times 100, if that equals 80%, I want to find X because I want to find the actual mass. So I can slowly simplify. So if I divide both sides by 100 first, I get X over 9.25 equals 0.8. Then I can cross multiply. So 0.80 times 9.25 equals X, which is the actual mass. So I'm going to multiply 0.80 by the actual mass, and I'm going to get 7.0 grams MgNO32, and that is actual. And remember that you want to keep the unrounded version of the mass in your calculator when you're multiplying by percent yield. So now I'm going to do the same thing with AgCl. I'm not going to do this long version. I'm just going to multiply 17.9 grams, which is the theoretical, by the percent yield. Again, I'm multiplying it by the decimal, 0.80, not by 80. And then I'm going to get 14.3 grams of AgCl as the actual mass. And so in this example, we are just solving for a different part of the percent yield equation. Rather than solving for percent yield, we're solving for the actual mass. So that is the first part of this example problem. Okay, so now this question says, if 476 grams of magnesium chloride actually produce 400 grams of magnesium nitrate, determine the percent yield of the reaction. What mass of silver chloride will be produced? So we have our starting mass for magnesium chloride, and we have our actual mass for magnesium nitrate, which is a product. So in order to determine the percent yield, we need our theoretical mass for magnesium nitrate. So that is going to be the first thing we are going to calculate for. So I'm going to input the numbers I have. I'm not going to put 400 grams because this table is representing theoretical masses. So let's just get started. So if we have 476 grams of MgCl2, we're going to convert that to moles by saying 1 mole MgCl2 over 95.21 grams. That equals 5.00 moles of MgCl2. Now we want to calculate the theoretical mass of magnesium nitrate. So I'm just going to go ahead and go straight to calculating grams. And by straight to calculating grams, I mean I'm going to do one large conversion instead of two separate ones. So I'm going to have 1 mole MgNO3 over 1 mole MgCl2, and then I'm going to multiply by the molar mass.
So when we multiply by the molar mass of 148.33 grams per 1 mole of MgNO3, I get 742 grams of MgNO3, and that is the theoretical mass. So now the next part of this question says determine the percent yield of the reaction. So I'm going to take my actual mass of magnesium nitrate, which is 400 grams, and then divide by 742 grams and multiply by 100%, making sure to keep the unrounded version of 742 in my calculator. And I'm going to get 53.9%. So now the last part of the question is what mass of silver chloride will actually be produced. So for that, I first need to find the theoretical mass of silver chloride. So I am going to take 5.0 moles MgCl2 multiply by 2 mole AgCl over 1 mole MgCl2. So I have 143.35 grams over 1 mole AgCl. So if I do 5 times 2 times 143.35, I get 1,433.5 grams of AgCl, and that is theoretical. So now I'm going to multiply that by the percent yield to get that the actual mass of AgCl is 773 grams.
So I hope you enjoyed this week's video on percent yield. Next week, I'm going to be talking about limiting and excess reactants, which is going to be another advancement on basic stoichiometry. So I hope that if you need help with that, you will join me back next week. Feel free to leave any questions you have in the comments below, and I will do my best to answer them. Again, I hope you enjoyed this week's video, and good luck with learning the rest of your chemistry.